Okay, section 13.6, solving quadratic equations by factoring. Let's go ahead and look down here. Let's remember that quadratic equations are equations that could be written in the form ax squared plus bx plus c. Let's also remember that how do we decide what the power is of a equation is always look at this first one right there. Notice this is a power of 2. That makes it a quadratic equation. Okay. Well, so make sure that a does not equal 0, because what would happen? Well, that would just zero that out, 0, and then you would just get c equals 0. So this would not be a situation. So let's just jump right into some examples. It makes it a lot easier. Okay. On this one, it's already been factored for you. Notice we have x minus 5 and then 2x minus 7 equals 0. On something like this, I'll come in here kind of with a different color here. And you'll see me do this a lot whenever we start doing a lot of examples from Hawks, is once I get into factored form, I'll come here and just draw a line. And then I know automatically that this side right here, x minus 5, it needs to equal 0. And then this 2x minus 7, this needs to equal 0. Okay? Once I do that, what we're going to do is we're just going to come in here and solve each side like normal. Add a 5 to both sides here. And then we're going to get x equals 5 on one side. On this other side, it's just a little bit more in depth, but you're going to add a 7 here. What I do to one side, I will do to the other. That is going to give us 2x equals 7. Notice to get that x by itself, I'm going to divide off the 2 off both sides, and then I'm going to get x equals 7 over 2. So x in this case can equal to, for the solution to this problem, is either going to be, x is going to either equal 5 or x could equal 7 over 2. Okay, let's go down to the next one. Notice we do have a quadratic equation. It's not in the form in what we like, so let's go ahead and get it into that form. What we're going to want to do is get this 6x over to the other side. To do that, what we're going to do is we're going to subtract 6x. Okay, so I'm just going to subtract 6x from here, and then I'll subtract 6x from this side. When I do that, I can rewrite this as 3x squared minus 6x equals 0. So notice we have our a, we have a b. There is not a c in this scenario. It would just be a 0, so we don't have to add anything. And then we have our constant 0. Let's go ahead and start solving. Now, one thing I want you to pay attention to is, if you remember, first thing on factoring is, notice we have this 3 and this 6. They are both common to each other. They're common multiples. But we also have this x and an x. We have x squared and x. So before you even start your factoring process, factor those out. I can literally come in here if I like and divide all that out. Notice 3x divided by 3x is going to give me a 1 there. So, or just leave me with an x. So I can factor that outside the equation. When I do that, I'm going to be left with x here. Well, 3x divided by negative 6x is going to still give me a negative. But now, everything in here is going to reduce down just to 2. Okay, because the x's are just going to cancel straight off. The 3 will cancel down to a 2. And now, my problem looks like this. Well, once again, come in here, draw your line. Okay, well, 3x. This, anytime you pull a constant out, I'm going to tell you it's automatically going to equal 0, but I'll show you anyway. So you have 3x equals 0 on one side. Then you have x minus 2 equals 0 on the other side. Well, if I divide 3 here, notice I'm still going to get x equals 0 on one side. Over here, I will add 2, to both sides, and that will give me x equals 2. So in this scenario, x can either equal 0 or x can equal 2. Let's do one more. Okay, this one's not factored. It is in the form we like it. Okay. Let's start looking at it carefully though. Let's remember back to 13.5. Could this be a perfect square? By perfect square, remember, perfect squares are any number multiplied by itself. So if I have 2 times 2 equals 4. 4 is a perfect square. 3 times 3, well, that equals 9. 9 is a perfect square. Well, do we see anything? Well, how about 4 times 4 equals 16? Notice this is a perfect square. Look right here. So going back to our old problem that we had from 13.5, the example, I don't even start having to play around with this. I can go ahead and just go, okay, well, couldn't I conceivably rewrite this as x squared minus 8x plus 4 squared equals 0? Because notice this right here, 4 times 4 is the same thing as 4 squared. That equals 16. Doing that, I can come down here and just go, okay, well, how about this? Can I not write this as x minus 4 squared? It would end up being the same thing. So, very simple on that one. You can also, this one's also called sometimes a double root or a double solution. So, in this scenario, since we've only got one, okay, I'm going to put this, I'm going to put this very intentional. We've technically only got one answer, because if I wanted to write this down, this is exactly what it would look like. Well, yeah, could I technically do this? Be kind of redundant. So instead of doing that, just know that I only have one answer. And when I do that, I'm going to get, when you add 4 to both sides, here, you're going to get x equals 4. So the solution to this problem is x equals 4. So, all right, let's just go jump in, do a bunch of hawks. Like I said, we'll do a bunch of examples in class as well. So don't stress.